Greetings and welcome to the pod. My name is Mark West. Crayweed is a type of seaweed that forms dense forests on shallow reefs all the way from Port Macquarie to Tasmania off the east coast of Australia. However, there is a 70-kilometre gap in crayweed off the coast of Sydney. Sometime during the 1980s, crayweed disappeared completely between Palm Beach and Cronulla, likely due to the poorly treated sewage that used to be pumped directly onto Sydney's beaches. However, despite Sydney's water quality improving dramatically since the establishment of the deep ocean sewage outfalls, the crayweed forests have not returned. Ziggy Marzanelli leads the crayweed restoration research at the University of Sydney and the Sydney Institute of Marine Science, and is part of Operation Crayweed, a concerted effort to restore Sydney's underwater crayweed forests. One of the places they are working is Cabbage Tree Bay near Manly, and they have enlisted the help of the ocean swimming group Bold and the Beautiful, and look out for a podcast episode about that in the near future. But for now, I started by asking Ziggy, what is crayweed and why is it important?
Crayweed is a seaweed that lives around the coast of pretty much from Port Macquarie up north in New South Wales all the way around the south coast of Australia and up on the west coast. But it actually went missing from Sydney. And seaweeds are actually quite important because in the same way as sort of trees on land, like eucalyptus trees, for example, form forests that underpin a lot of the animals and plants that provide a lot of services to us on land. In the same way, forests underwater are formed by seaweeds, like crayweed. And there's a lot of diversity that is underpinned by specifically crayweed itself. Like, for example, we find higher numbers of abalone, lobster, and also little animals that actually feed higher up in the food chain to things like leather jackets and snappers and things like that. So we started by first figuring out that actually went missing, and it only went missing from the stretch of coastline, about 70 km of coastline around Sydney. And then we started developing methods to actually figure out if we could actually bring it back, not only crayweed itself, but also all the diversity that crayweed underpins and that went missing when this underwater forest went missing. So in collaboration, this is a large collaborative project, so it involves University of New South Wales, University of Sydney, people from the Department of Primary Industries, Fisheries New South Wales, all around the Sydney Institute of Marine Science, which is a hub for marine ecology and marine science generally here in New South Wales. So once we pinpointed what happened and why it went missing, we started developing experiments to actually test whether we could actually bring it back. And those were extremely successful. And then from then on, we started scaling up. And the goal really is to bring back crayweed along those 70 km of the Sydney coastline where it used to be really abundant and healthy. And about 40 years ago, it disappeared and it never came back.
That's really interesting. So why did it disappear and why from just that small stretch?
Yeah, so that's a very good question. So if you go back in time, so essentially Sydney around the 60s, 70s was growing quite fast. There's a lot of population around and living on the coast and using the coast. But sadly, the treatment of, for example, sewage was really bad at the time. And actually, sewage was pumped right onto the coastline. There were protests around the 70s and early 80s in Bondi Beach, for example, because people didn't want to even get in the water because of the really poor quality there. And the government responded to that. And what they did is in the early 90s, they improved the treatment of sewage. But most importantly, what they did is they actually decommissioned all the sewage outfalls that were right on the beach. And they built these new outfalls, which are the ones that we have now that pump the sewage really, really far away. And basically, the increase in water quality was dramatic. Only a couple of years afterwards, you look at the data back then, and the water quality improved significantly. And you can see today, you guys swim a lot, I go surfing and so on. The water is really, really, really nice. And the quality of the water, given that we live in a highly densely populated city compared to other cities around the world is actually fantastic, right? However, the interesting thing is that despite that significant and rapid improvement in water quality, this species did not come back on its own. So that was that change in water quality happened in the early 90s, and we and colleagues of ours did surveys to figure out where Crayweed was missing from, and those surveys were done in about 2007, 2008. So it's been like almost 30 years, and until now, more than 40 years since that happened, and this species has not been able to come back on its own. And this is not specific of Crayweed. If you look at the literature in general, not only marine systems but also in systems on land, there's a lot of examples where once you remove the cause of degradation or mitigate it, those systems do not recover on their own. So that's when you need to start thinking about doing something about it and some type of intervention. And ecological restoration is one of those types of intervention. And here what we did is, number one, once we knew that the cause of the problem, the initial problem, was mitigated, and water quality actually improved to levels that these species can actually healthily grow, we tested that by basically bringing adults from surrounding populations in Sydney and planting them in sites in Sydney where we knew it used to occur before all these problems. And what we found is that they actually reproduced. They had babies, we call them Crayweeds, and those Crayweeds eventually grew and became adults, and they themselves started reproducing, and those populations started expanding. So we have one of our oldest sites is about 8 years old, and we have Crayweed growing 300 to 400 meters away from the initial planting site. So, you need to, these things take a while because of the way they reproduce and the way they grow and so on, but still that is quite surprising. And it actually shows that if you do small-scale interventions, so in this case, small-scale transplanting of reproductive adults into a site, then through time, the conditions are good enough that it actually those forests start expanding, and you start getting back certain components of biodiversity that you lost when those forests disappeared in the first place.
So are there associated fish coming back and other animals as well?
Yeah, so we've been basically surveying those sites where we planted Crayweed, and those Crayweeds have actually started expanding. And we also survey sites where Crayweed never disappeared, so outside of Sydney. Those are sort of our goals. That's what we want to achieve. We want to achieve forests that look like the ones in sort of more pristine areas or areas where it never disappeared. And then we also survey sites in Sydney where we haven't planted Crayweed yet. So those are sort of like what we call control sites or degraded sites where we haven't actually done anything. And what we're seeing is that through time, there are certain species of fish and also a lot of little creatures, little animals that actually live on the Crayweed that are food then to higher trophic levels, higher like larger fish and so on, that are starting to come back. And they resemble to a certain extent what we find in natural Crayweed forests in areas outside of Sydney where they haven't disappeared. They've always been there.
And so will it eventually connect up to areas out of Sydney? Is that the end goal, or is that way too big?
Yeah, exactly. The end goal is to basically have the Crayweed distribution of those forests go from Port Macquarie all the way down and around the south coast. So we basically not having the gap that we currently have around Sydney. And the interesting thing about this project as well is that we can actually achieve that because the scale of the issue is not that large. It's only 70, I mean, it's hard work and so on, but it's 70 kilometers of coastline. Like if you compare this, for example, with the issues we're facing in the Great Barrier Reef, which is huge, right? And, the type of interventions that are proposed for that scale of a problem usually are not enough. They are not really addressing the problem at the right scale. Here, we can actually address the problem at the right scale and actually fix it. So we actually have a solution in hand that we can actually fix this problem and revert this issue. So again, I think there's a lot of things that play here. One is that the cause of degradation, so poor water quality, that was removed, and water quality now is good enough to have these species and for it to reproduce and grow and survive and so on. And then the second one is that the scale of the degradation is actually manageable. We can actually do small-scale plantings like the one that I described before, and these species, basically, once you do that, you're setting them in the right trajectory for recovery. And through time, what we've seen is that in most places, they actually start reproducing. They have Crayweeds, those Crayweeds grow, and the thing goes on.
How much do you think will get taken care of for you? So once you've set the crayweed in the mesh and they start breeding, how many places do you have to do that around Sydney for it to eventually come back? Or do you have to be really involved over the next 10 years or something to make sure it comes back to certain spots?
Yeah, that's a very good question. So, for example, we know that along those 70 kilometers of coastline, not everything is rock, right? And these algae, seaweeds, grow on hard substrata, so on hard rock. So there's a lot of sandy places where it wouldn't naturally occur. So those we don't need to worry about basically because it was never there, right? So there's about like 25 or so rocky reefs or rocky headlands along that 70-kilometer stretch of coastline, and those are the ones that we're targeting. And the way we're doing it is by sort of following our methods that we have developed through experiments, which is doing these small-scale plantings, which then through time they alone basically start expanding. Of course, the real world is variable. Some places work better than others. For example, in some areas, we typically find that we need to replant after the initial planting because, for example, you get schools of fish, the herbivorous fish, for example, that come in and graze a lot of individuals, and therefore you're losing all that reproductive input from those that you brought in from surrounding populations. In some other areas, sea urchins may be a problem as well. So it's site-specific, but in general, I would say that about 50% of the places we've done so far, you get recruitment sooner or later. So you get those Crayweeds, and then they grow and they start expanding. One of the key things here is that we also want to involve the local community because one of the characteristics of people in Sydney, especially people that live close to the water, is that they enjoy being in the water and they love protecting their environment. So we engage with a lot of local dive clubs, for example, that helped us with the actual planting of Crayweed at some of the sites. Swimming clubs like the Bold and Beautiful in Manly, who have actually helped us planting as well, and also keep an eye on how these patches go, and they actually let us know when they see new Crayweeds growing around the patches. They keep an eye on people not disturbing our plantings underwater. So it's amazing how people actually care about the environment here, and they want to give us a hand. And at the same time, not only people that like conservation, but also people that like fishing, because fishermen know that if you bring Crayweed back, you are bringing back, for example, higher numbers of lobster. Potentially that will help abalone to come back as well. There's other species of fish that like hanging out in Crayweed. So it's a win-win situation for everyone, basically. So we've been really lucky that a lot of people have contacted us and want to give us a hand. And that ranges from helping us on land with logistics, but also some people in the water actually doing the planting themselves. Like, for example, Abby's Dive Club, they actually help us plant one of the sites as well.
Oh, that's really cool. And it's some of those places you mentioned, like the Bold and the Beautiful, swimming out at Manly and Cabbage Tree Bay. They're really beautiful places, and that's a marine reserve now, I think, as well. So there's a lot of marine life over there, which you'll probably be enjoying this extra Crayweed.
Yeah, so that's a really great point. So the planting with Bold and Beautiful, that I believe you're going to talk to Dorset Sutton. So Dorset and his wife Jenny Lim, they basically heard about the project, and they really wanted to support it. And they've been really champions at supporting our project there, and fundamental to make it happen, because this is the main difference between our planting at Shelly Beach versus the other ones that we've done before is that, as you just mentioned, Shelly Beach is an aquatic reserve. So people are really care about that area, and they're really protected about that area. So we had several processes where we talked to the town hall. We talked to different stakeholders in the community there, and Dorset and Jenny were key in sort of getting those connections and talking to these people to basically explain the problem and sort of let them know that what we are doing is actually bringing back something that used to be there, but it's not there anymore because of us. And by bringing it in an aquatic reserve, we're actually potentially enhancing its chances of success because, as you said before, those systems, because they've been protected for a while, they're usually more resilient to other stressors. So this is a great opportunity to actually test that and bring back something in a place that is actually has been protected for a while, and therefore there's a lot of biodiversity out there that may help Crayweed develop and grow and support more diversity in that area as well. And the advantage of that is because people really care about that area. They are really protected. So they really take care of our plantings, and they report back to us, and they're really engaged and interested. And the same thing with their kids. It's fantastic, the engagement we had with public schools around the area. Kids love it. We actually created in collaboration with Turpin and Crawford Studio, Jenny Turpin and Michaeli Crawford, who are artists. We actually created an art meets science type of video used with the school kids who actually engage with the project, which is great. Like, what you want is for the younger generations to actually understand the issues we're facing and care about the marine environment. So I think it's been a win-win situation. I love that part of the project, basically.
I was just browsing your Facebook page, actually, the Operation Crayweed Facebook page, and you do quite a lot of outreach. There's outreach with schools and different parts of the community. It's really great how you're kind of reaching out into all these different aspects of the community.
Yeah, again, it's as I mentioned before, it's a huge project, and there's a lot of people involved. So I'm just talking here today, but there's a lot of people from, as I said before, multiple institutions, but also, as I mentioned before, artists, people that are supporting the project financially, but they also have a passion about it, and they want to engage with the community. So I think it's fantastic in that sense. And as I said before, I'm the one talking here, but there's a lot of people involved that help us all the time from all these different institutions that I mentioned at the beginning.
Is crayweed disappearance a problem in other parts of the country or in any other part of the world?
Crayweed is only native in Australia. So it's a species that actually occurs only on the southeast coast of Australia. The issue we're facing now in this part of the world, I mean, you hear people talking about ocean warming and acidification, future issues in marine environments. Seaweeds actually are some of the species that are likely to suffer the most in this part of the world, because the southeast coast of Australia is actually warming at a much faster rate than other places in the world. And seaweeds like cooler waters, especially species like crayweed and the common golden kelp that you see when you go swimming as well in this part of the world. So those species are, based on experiments that we've done and other people have done as well, those species are going to suffer a lot if water temperatures continue to increase. And the issue we find here in Australia, as opposed to other places in the world, is that once you reach the south of Tasmania, there's nowhere else to go. I mean, these species cannot sort of like jump all the way to Antarctica. So what we're going to potentially be seeing is range contraction of the distribution of some of these species. So you're going to lose some of the forests up north, but they're not going to expand elsewhere because they don't have anywhere else to go. So now one of the things that we are trying to, and not only us, there's other people that work on underwater forests of similar species of seaweeds in Australia and around the world, is trying to figure out ways in which we can actually fight this issue of warming. Because, for example, in our case with crayweed, we are restoring crayweed now, but we also want it to be here in 100 years' time, for example, right? But in 100 years' time, we know waters are going to be warmer. So we're trying to figure it out and understand for example, which populations may be more resilient to increases in water temperature or to heat waves, for example. Can we use those populations for the plantings that we do here, so that the populations we're creating here have actually some some component of those that are more resistant or resilient to future conditions.
It's interesting that like crayweed and other seaweeds are significant carbon sinks, aren't they, as well?
Yeah, so crayweeds are and other seaweeds are, especially large brown seaweeds. They grow really fast. So for example, some of the fastest growing macro sort of like they're not strictly plants, but they're sort of like trees underwater. Like giant kelp forests down in Tasmania, for example, they can actually grow really, really fast. They are some of the fastest growing primary producers in the world. So by doing that, they're actually accumulating carbon. One of the key questions that is a topic of research from a lot of colleagues around the world is, where does that carbon end up? Because we know that they're actually capturing it. Does it go back into the environment, or is it sequestered? And that's a very key question from the point of view of climate change, because potentially there's a lot of investment in planting forests on land. Potentially you could also sequester carbon by planting forests underwater. And that's a win-win situation, because you are restoring some of damaged places by planting these crayweeds, and you're getting the benefit of not only bringing back these forests and all the diversity and so on, but also potentially sequestering a lot of carbon. So yes, that's absolutely true. And there's a lot of research at the moment being done on trying to determine the fate of the carbon.
So Tasmanian kelp forests are quite famous, or at least I knew of them, and they've been largely wiped out as well, haven't they? That's not through sewage? Is that through human use in some other way, isn't it?
So yes, Tasmanian kelp forests, the main kelp forest, well, those forests are formed by different types of species, of which probably the two most important ones down there from the point of view of degradation are the golden kelp, the same one that we find here, and that basically is the same species that is distributed across the bottom half of Australia. And then you also have the giant kelp forest, which is the one that I was talking before, that they're basically like really tall trees. They grow up to 30, 40 meters from the seabed all the way up to the top, up to the surface. And they're experiencing declines of both species. So the golden kelp, and both of them is related to ocean warming. So the golden kelp, what happened is around the 1950s, the long spine sea urchin that we have here started. Those urchins reproduce by they release their gametes to the water column, and then you have a larval stage. So it's an urchin larvae that lives in the water column from weeks to months. The intensification of the Eastern Australian current has delivered larvae of this urchin to Tasmania, where it never used to occur before. And then from the 1950s, they started seeing these urchins getting to the northeast coast of Tasmania on the tip there. And then through time, what they've seen is expansion of this urchin further south as the Eastern Australian current intensifies. And those urchins there have created massive issues, because they really like consuming this golden kelp. And once they reach a certain abundance, they sort of form these barrens, and it's like an army of urchins really grazing on these kelp forests. And the number of barren areas, so areas where there used to be kelp, but they were consumed by urchins, and now they're basically bare rock, has increased through time along the east coast of Tasmania from the 1950s until now, and that's been a huge problem in Tasmania. And then the second species, this large giant kelp, which is similar to the one that you find on the west coast of the U.S., that forms this amazing forest of 30 meters or so, also declined through time due to increases in water temperature, and to the point that there were lots of populations along the east coast of Tasmania, and there are fewer and fewer, and the final ones are sort of really in the very south tip of the coast. So there's a lot of work in Tasmania by colleagues trying to figure out ways in which you can grow this giant kelp in the lab, use genotypes that may be more resistant to increases in water temperature, and then replant those and see if you can reestablish this giant kelp forest using individuals that are more resistant or resilient to increases in water temperature. So it's huge efforts down in Tasmania. to try to fix this issue. And there are similar efforts being done on the west coast of Australia, the south coast, and also by us on the east coast. Because this is a problem, generally speaking, the declines of these underwater forests. It's a problem that we're facing here in Australia, but also in other places around the world. So it's a massive efforts of people trying to figure out what are the local causes of degradation, how do they interact with large-scale stressors, like, for example, warming, and then how to fix the issue, how we can actually come up with solutions that actually work. So there's and there's a lot of effort being put in, and more there's a lot of people, different stakeholders, and the general public really interested in helping and contributing to this, because they realize that when you lose these forests, you lose, from the point of view of like the beauty and swimming in the ocean with all this life, you lose that life. And then from a fisherman point of view, you're losing a lot of the fish that we actually catch for consumption, that we need as humans. You lose carbon capture, that is a service that these forests provide, and so on. So there's a lot of ecosystem goods and services that we lose when you lose all these forests.
That sea urchin and the East Australian current is fascinating. So the sea urchin is kind of like an underwater cane toad, really. It's sort of been introduced and destroyed the natural environment.
Yeah, so here in New South Wales, for example, that species of urchin is native, so it was always here. But in Tasmania, it wasn't. Right. So it only got there because of the intensification of the Eastern Australian current. So it's sort of like Nemo, the movie from Disney, but with urchin larvae that started getting into Tasmania, and it caused a massive problem. And the intensification of the Eastern Australian current is because of us. It's related to how we are changing the climate of our planet. So as I said before, it's a combination of large-scale problems and stressors like ocean warming, with small-scale things like, for example, in the case of Crayweed, water quality. Some of them are much easier to fix than others. In our case with Crayweed, if we wouldn't have been able to fix the water quality problem, whatever we do after wouldn't have worked, because you need good water quality for these species to live and reproduce and so on. So similarly, if we want to restore forests in places where the issue is increased water temperature, we really need to fix that problem first. So there's a lot of push to actually understand the causes of declines, fix them or at least mitigate them, and then, given the rapid declines, combine them with other solutions, like, for example, increasing resistance or resilience of those populations that you're using for planting, because otherwise it's going to be too late. So yeah, it's a complex and sad story, but at the same time, they are really good news stories that we should tell people about, because we can fix some of these issues if we actually put our efforts into it. Like an example is Crayweed. The government fixed the sewage problem in the early 90s. That increased water quality, and then it was just a matter of figuring out what was preventing Crayweed from coming back on its own, and giving that initial push. So those small-scale plantings in areas where it disappeared but it never came back, to actually set the system in the right trajectory and let it recover. So I think we need to tell people that it's not all doom and gloom. So we need to tell people that there are cases where you can actually solve the problem, and science is a way to do that in collaboration with stakeholders and engaging with the community. Because at the end of the day, if you have the community on board, then it's much easier to carry on these projects and get the support.
And so if people would like to get involved with Operation Crayweed, what should they do? What would be their first thing to do?
So we have, as you mentioned before, we have a website, which is operationcrayweed.com, where there is contact details there. We also have a Facebook page. So if you Google Crayweed, you'll see the website there, the Facebook page there, and you can contact us through that page as well. And you can always send us individual emails. Like, for example, if you Google my name, if you Google Ziggy Martinelli, you'll see my University of Sydney website and my email there, so you can contact me directly as well. And then we, as I mentioned before, we are always keen on getting the general public involved. Of course, there are some, health and safety things and so on. But as I said before, people can help even from without getting wet on the water, from the logistics side of things, helping us preparing the way we plant these individuals before we get them in the water, and so on. So there's many ways in which people can help us.
So you're in your daily life. You're with the School of Life and Environmental Sciences at Sydney Uni. Is all your work around this area and restoring biomes like this?
In general, I'm a marine ecologist, so I try to understand what basically creates, maintains, and impacts marine biodiversity and marine functioning. So I do work a lot with underwater forests of seaweeds because they are a key fundamental habitat here in our coastlines. But I do a lot of stuff around understanding interactions between things that you cannot see, like, for example, microbes, bacteria, and so on, and these large marine organisms like seaweeds and so on. And then the idea is try to figure out, in the same way, for example, as there's more and more understanding on how, for example, our gut microbiome, the bacteria that we have surrounding us and inside us, are actually really key for us to digest food and live healthy and so on. Try to understand which microbes are fundamental for example, seaweeds or crayweed to actually reproduce and grow and be healthy. So there's a lot of research that I do that is along those lines, basically. And I guess the applied side of things would be, understanding that, for example, can help develop similar things to probiotics, for example, for underwater forests, and similar things like that.
That's a fascinating idea because you can imagine if the whole forest has been wiped out and then you introduce crayweed back, all the rest of that bacteria and whatnot's not just going to magically reappear. I mean, maybe the currents will bring it there, and over time, maybe it'll get a foothold, but it's not going to happen just instantly or kind of just magically, is it?
Yeah, there are fundamental questions of, for example, given that, and there's a big difference between animals and plants on land versus the ones in the water, because on land, the amount of bacteria and other microbes in the air is really, really, really low compared to what you find in the water in the oceans, right? So you can think about these plants and animals being in a soup of microbes. So, and the diversity of microbes in the oceans is, for example, some of the round numbers is about, it's higher than the number of stars in the universe, right? As far as we know.
Wow.
So it's incredible diversity, incredible abundance. So how do those microbes that associate specifically to these species and that actually help these species function well and be healthy and so on, how do they come to be? Where do they come from? Do they, given that there's a soup of microbes, how do they, why do you get certain specific microbes on those species relative to other species? Which ones are the ones that are good? What happens when conditions change and become, the environment becomes unhealthy? Like, for example, there is a spike in pollution or water temperatures become warmer. What happens to those microbes? Do those microbial communities change? Do you get more pathogens that actually then lead to disease? And is that one of the mechanisms that may explain why we are seeing declines of these forests? Is it microbially mediated? Like, for example, with us, you can get a viral infection or a bacterial infection because you're stressed. You have higher chances of getting that, and that may be the underlying mechanism by which you get sick. Similar questions with marine habitat-forming species like seaweeds that form these forests that are really productive.
Oh, that's fascinating. So the speed of evolution must be very fast in the ocean as well. There must be a lot of untapped. There must be a lot we don't know, I imagine.
Yes, yeah. Especially when you start digging into the microbial world. There's been a revolution in methods and techniques that allow you to understand all this massive diversity and abundance of microbes in the oceans and on land as well. And we are learning, more and more. Basically every day you learn new things. So now we're getting to the point where we can really ask questions about what drives what and what is the mechanism behind it. And then hopefully by understanding that, we can potentially use that understanding to enhance our, for example, our restoration efforts in the case of seaweeds, or for coral reefs, for example, or for other systems as well. So again, it's one aspect that may help us achieve goals that relate to preventing further degradation to marine environments, and also try to enhance restoration or recovery of some of those environments. But as I mentioned before, you need to couple that with removing the initial costs and mitigating the cost of degradation. Because for example, in the case with microbes, you can give a lot of probiotics to a person, but if the person keeps smoking, for example, then it's not going to work. So in the same way, if water temperatures continue to warm, it doesn't matter what you do to a certain extent. You really need to tackle and address that problem first. So then you can allow recovery and restore systems and so on.
So what's next for Operation Crayweed, or what's next for Ziggy Marzinelli?
So for Operation Crayweed, we really want to achieve that goal of bringing it back at the scale of degradation, so it really solve the problem at the right scale, which would be unique for these systems. And we have a great opportunity here because the scale is actually manageable. So we continue to reforest some of those places, some of those reef headlands around Sydney. And then obviously there's a lot of problem solving in some places. As I mentioned before, some places work better than others. So then it's about science and figuring out what is preventing recovery in some places and how can we enhance it and so on. And then at the same time, continue to engage with the public, because as I mentioned before, especially with the kids in schools and so on, because if they understand there is a problem, they're the ones that are going to be solving all these environmental issues in the future as well. And protecting the marine environments in the future. So I think that's a big component of the project as well. And my colleague Adriana Verges from UNSW, she's been championing that side of the project. And then in general is to basically continue to do research and discover new things. This is what science really is about. It's about discovery. So then you can understand really how systems work, and that allows to develop solutions that can be successful in the face of all these changes that we're facing.
That's really cool. That's really exciting. I mean, it's the problem is obviously representative of a really big issue, but what you're doing is really quite exciting, I think.
Yeah, I really like to reinforce the point that there's a lot of people involved here, and it involves a lot of institutions, especially around the Sydney Institute of Marine Science, and together I think we're doing a great job. And I think science in general is becoming more there's a lot of more collaborations going on in science, because the nature of the problem and the scale of the problem, right? And more it's known that you need to involve the general public and the communities and so on. Social science is becoming more important as well, to couple it with just not only just doing marine ecology or marine science. You need to couple that with engaging the general public and understanding how to engage the general public and so on. So I think, it's a big team of people, and the good thing is that we're all pushing to the same direction, and hopefully we can actually address the Crayweed problem in Sydney and bring it back to the whole gap in that coastline, and then hopefully we can learn from this relatively small project, and then try to and that can guide us to other larger projects regarding issues that are occurring at much larger scales. So the final point is, if you want to help us, just contact us through our website or our Facebook page. And the second thing is that you guys will hear hopefully from some of the people that are helping us achieve this project in places, for example, like Cabbage Tree Bay, and engaging with the community there, like Dorset, Sutton, and Jenny Lim. And it would be really interesting to hear their perspective on the project and why they got engaged with the project and so on, because these people are not scientists, but they're really passionate about the environment. So it would be really interesting to hear more from them about how did they hear about the project? Why do they want to engage with this project in particular, and so on. So I think that would be interesting to hear. And in the same way as Thorsten is championing the project in Sherry Beach, there are other people, like, for example, Tom Breen, helping us restore Crayweed and golden kelp in other areas in Sydney. So there's a lot of people like that, with no science background, but are really passionate about the fixing problems in the environment, basically. So I think hearing from them too, I think it's great.
Thank you very much to Dr. Ziggy Marzanelli for taking the time to chat to me about Operation Crayweed. If you'd like any more information on anything you heard in this episode, get over to the website at www.thepodpodcast.net. That's www.thepodpodcast.net. Over there you'll find links to Operation Crayweed and the Bold and the Beautiful swim group if you want to get involved yourself. Thanks very much. I'll catch you next time on the pod.